Good afternoon, children. Today let me learn about theories of catalysis. For a chemical reaction, the reactant are to be activated to form activated complex. The reactants are to be activated, highly reacted to form activated complex. The energy required for the reactants to reach the activated complex is called activation energy. What is meant by activation energy? The energy required for the reactant to reach the activated complex. To form an activated complex, how much energy need? That energy is called activation energy. The energy required for the reactant to reach the activated complex is called activation energy. The activation energy decreased by increase in the reaction of temperature. Temperature increased, activation energy decreased. In the presence of catalyst, the reactant are activated at a reduced temperature. In other words, the activation energy is lower. Okay. So the catalyst absorb the reactant, activate them by weakening the bonds and allow them to react to form the product. Activation energy is lower, presence of catalyst. More molecule take part in the reaction. So the action of catalysis in chemical reaction explained by two theories. First theory is a intermediate compound formation theory. Second theory is a adsorption theory. Two theories: intermediate compound formation theory, the adsorption theory. First, let me learn about intermediate compound formation theory. A catalyst acts by providing a new path with low energy of activation. In a homogeneous catalyst, in an intermediate compound, we will use the homogeneous catalyst. That means reactant, catalyst and product are in same phase, maybe solid or liquid or gas. Okay. So in a homogeneous catalyst reaction, a catalyst may combine with one or more reactant to form intermediate. First, that catalyst react to the reactant to form the intermediate compound. Again, the intermediate compound react with the other reactant to give products, and the catalyst is regenerated. So this reaction is called intermediate compound formation theory. Consider a general equation: A plus B gives AB. Okay, A plus B gives AB. A and B is a reactant, AB is a product, C is a catalyst. Okay, first one of the reactant reacted with the catalyst C to form AC. AC is a intermediate product. A is a reactant, C is a catalyst. So one of the reactant combined with the catalyst, intermediate. Then again this intermediate reacted with another reactant B to form AB plus C. Catalyst is regenerated. Activation energy for the reaction 2 and 3 are lower compared that first reaction. Hence the formation and decomposition of the intermediate accelerate the rate of reaction. Example, the mechanism of Friedel-Crafts reaction. Benzene, the formula C6H6. Benzene reacted with chloromethane CH3Cl in presence of anhydrous aluminum chloride to form C6H5CH3 methyl benzene plus HCl. Okay, so here AlCl3 is a catalyst. Okay, so according to the intermediate compound formation theory, one of the reactant reacted with the catalyst. First step, first reactant and catalyst. So the first second reactant and the catalyst CH3Cl plus AlCl3 to form a intermediate compound CH3 plus AnCl4 minus. That intermediate compound again reacted with another reactant benzene. Okay, to form the compound C6H5 CH3. Methyl benzene plus aluminum chloride and HCl. Another example, the decomposition of potassium chloride in presence of MnO2. So the reaction is potassium chlorate decomposed to form potassium chloride and oxygen. Here we are using the catalyst is MnO2, manganese dioxide. Okay, so first one of the reactant reacted with here only one reactant is there. Okay, so that reactant reacted with catalyst. So the first step, KClO3 plus MnO2 gives MnO3. Okay, so MnO3 is a intermediate. Then MnO3 again dissociate, it regenerate the catalyst MnO2. Third example, formation of water due to the reaction of hydrogen and oxygen in presence of copper can be given. Okay, so copper oxidized to form Cu2O. Okay, so here the copper is a catalyst. That Cu2O is intermediate. Cu2O reacted with hydrogen, it regenerates the catalyst copper. Next, another one example is oxidation hydrochloric acid by oxidation of hydrochloric acid by air presence of cuprous chloride CuCl2. Okay, CuCl2 dissociate to form chlorine and cupric chloride. Okay, Cu2Cl2. Cu2Cl2 again oxidized to form Cu2O Cl2. Cu2O-Cl2 is an intermediate. Okay, intermediate again reacted with HCl to form H2O plus CuCl2. CuCl2 is a catalyst. This theory describes the specificity of catalyst. Then this theory, intermediate compound formation theory, increase in the rate of reaction with increase in the concentration of the catalyst. The limitation of intermediate compound formation theory. The intermediate compound theory fails to explain the action of catalytic poison and activators. It failed to explain catalytic poison and activators, that means promoter. Second limitation, this theory is unable to explain the mechanism of heterogeneous catalyst reaction. Intermediate compound formation theory, it is useful for homogeneous catalyst reaction, unable to explain mechanism of heterogeneous catalyst reaction. Then second theory is adsorption theory. Longmire explained the action of catalyst in heterogeneous catalyst reaction based on adsorption. The reactant molecules are adsorbed on the catalyst surface. Okay, first the reactant molecule adsorb. Adsorb means in the surface phenomena, adsorbed on the surface of the catalyst. So this can be also be called contact catalyst. Adsorption theory is also known as contact catalysis. According to this theory, the reactants are adsorbed on the catalyst surface to form an activated complex. Okay, so reactant adsorbed on the catalyst surface to form an activated complex which subsequently decompose and give product. That activated complex decompose to give product. The various steps involved in heterogeneous catalyst reaction. The first step is the reactant molecule diffuse from bulk to the catalyst surface. It is adsorbed on the catalyst. The reactant molecule adsorbed on the catalyst surface. The reactant molecule are adsorbed on the surface of the catalyst. Okay. So at the adsorbed reactant molecule are activated and form activated complex, which is decomposed to form product. That activated complex decomposed to form product. The product molecules are desorbed. Okay. The product diffuse away from the surface of catalyst. That is adsorption theory. Next, let we learn about active centers. Active center. The surface of a catalyst is not smooth. Okay, this surface is not smooth. It bears steps, cracks, or corners. Hence, the atoms on such location of the surface are coordinately unsaturated. Okay, these substances are coordinately unsaturated. So they have much residual force of attraction. Such sites are called active centers. Okay, so this double bond unsaturated compounds the surface of a catalyst is not smooth. The surface are not smooth. It bears step, cracks and corners. Because the atoms on such a location of the surface are coordinatively unsaturated. So they have much residual force of attraction. Okay, so the force of attraction between that molecules. Okay, force of attraction. Such sites are called active center. Force of attraction and that places are more. That center is called active center. Okay. So the surface carries high surface free energy. The presence of such centers increase the rate of reaction by adsorbing and activating on the reactant. So adsorption theory explains increase in the surface area of metal and metal oxide by reducing the particle size, increase acting of catalyst and hence the rate of the reaction. Surface more, that higher surface. Okay, increase the surface area of metals and metal oxide by reducing the particle. That surface area more, it reduce the metal and metal oxide. Increase acting of the catalyst, hence the rate of the reaction. The action of catalytic poison occurs when the poison blocks the active center of the catalyst. Okay, so here catalytic poison. Okay, when that position active centers, when the catalytic poisons block the active center. A promoter activator increase the number of active center. Catalytic poison block the active center. Promoter increase the number of active centers on the surface.